Galaxies that defy conventional norms are stretching across the cosmos like surreal surfboards and interstellar pool noodles. I mean, literally, it might sound like an extraterrestrial daydream, but it is an astonishing reality. What if our understanding of galaxies is about to take a mind-bending leap into the extraordinary? What unseen forces shape these unconventional galaxies, and how do they defy the norms we thought were written in the stars? Join us on a journey beyond the ordinary as we dive into the unknown that makes us rethink everything we thought we knew about space. Are you ready to venture into the uncharted territories of our universe? Then stick with us until the end of the video. It's a revelation that shatters the very foundations of our cosmic understanding. According to a study led by Viraj Punda, a NASA Hubble Fellow at Columbia University, between 50% to 80% of observed galaxies, from when the universe was between 600 million to 6 billion years old, were not your typical neatly rounded structures. No, they were flat and stretched out, defying our expectations and rewriting the cosmic rulebook. It's a mind-boggling thought, isn't it? Haowen Zhang, a co-author of the study and a PhD candidate at the University of Arizona, suggests that the James Webb Space Telescope, JWST, has provided new evidence allowing scientists to estimate the mass and potential shape of our very own galactic home billions of years ago. But the surprises don't end there. The study reveals that these peculiarly shaped galaxies of the past were significantly less massive than the spirals and ellipticals we're familiar with today. Karthik A., another co-author and NASA Hubble Fellow at Columbia University, emphasizes the importance of identifying these early galactic categories, opening up new avenues for understanding the mysterious ways in which galaxies form and evolve. Now armed with its advanced capabilities in infrared imaging, JWST is capturing these distant galaxies with unprecedented detail. Its high-resolution images and sensitivity allow scientists to delve into the three-dimensional geometries of these ancient cosmic structures, building upon the groundwork laid by the iconic Hubble Space Telescope. But there's still much we don't know. The research team acknowledges the need for a larger sample size from JWST to refine our understanding of the properties and locations of these distant galaxies. Now, take a moment to consider the implications. What if we could witness our own Milky Way in its ancient days? Would it have looked more like a surfboard than the familiar spiral we recognize today? What do you think? JWST's first year of observations has been nothing short of a roller coaster, turning up thousands of distant galaxies dating back to the early universe. They are bigger, brighter, and more mature than astronomers had ever expected. It seemed too implausible that their light had shone across the universe from about 13.3 billion years ago, less than 400 million years into the universe's existence. But then JWST stepped in, aimed its massive mirror, and validated those claims. The galaxy's light is indeed ancient, dating back to just 390 million years after the Big Bang. And it's not alone. The JWST has unveiled a multitude of distant galaxies, each with its own story to tell. Brighter, more massive, and more mature, these galaxies are rewriting the cosmic narrative. Stephen Finlin, an astrophysicist at the University of Texas at Austin, confesses that he was expecting to find some galaxies at this distance, but the sheer magnitude of the discovery has left even seasoned astronomers like him in awe. For those who have been in the field for a while, this might feel like déjà vu. In the 1990s, the Hubble Space Telescope peered into what seemed like an empty patch of sky, only to unveil thousands of galaxies from when the universe was only a billion years old. Those galaxies looked mature, as if they had already been through cosmic adolescence. It was a revelation that spurred the quest for even earlier galaxies, leading to the birth of JWST. But that's not the only thing that the James Webb Space Telescope has achieved. The next thing I'm going to talk about is another enigma that might intrigue you very much. Galaxies seemingly defying the bounds of cosmic distances. With redshifts of 10, 13, and even 17, some appear faint and diminutive as expected, while others defy expectations, gleaming bright and substantial. Astronomers, as part of the JWST Advanced Deep Extragalactic Survey (JADES), set out on a mission to confirm the distances of galaxies with photometric redshifts higher than 10, a potential gateway to the era of reionization, a celestial surprise. A galaxy now known as JADES GSZ 110 claims the title of the most distant ever confirmed, with a redshift of 11.58. Another, with a redshift of 13.2, beckons from a time just 325 million years after the Big Bang. The spectra analyzed by the team offer a glimpse into the galaxy's properties. These celestial entities, a mere hundredth the size and mass of the Milky Way, astound with their prolific star formation rates in this cosmic drama. Newborn stars emit ionizing radiation, hinting that these galaxies might be among the earliest architects of reionization. Identified in JWST images for the Cosmic Evolution Early Release Science Survey, SEERS, Galaxy SEERS 93316 initially claimed a redshift of 16.4, a potential record breaker. However, when the spectral data emerged, the redshift plummeted to 4.9, a reminder that the cosmic stage can be full of surprises. Finlin, the lead researcher of the SEERS survey, acknowledges the occasional deviation, labeling it a pathological case rather than a devastating setback. This revelation eases the burden on JWST's observing schedule, allowing astronomers to trust in the legitimacy of most redshifts, saving detailed spectrographic analysis for the truly intriguing cosmic entities. Thus, the JWST has uncovered a celestial surprise, a twist in the tale of galaxy formation. But it appears that there are more brilliant galaxies dancing around at redshift 10 than our esteemed cosmologists had foreseen. But what does the brightness of a galaxy really signify? It's a cosmic billboard, a luminous sign indicating the mass of the galaxy and consequently the abundance of stars within it. The brighter the galaxy, the more stars it flaunts, illuminating the cosmos with their brilliance. Cosmologists, armed with simulations and theoretical frameworks, had a rough estimate of the number and size of these dark matter halos when the first galaxies took their cosmic bow. They envisioned the grand assembly of galaxies fueled by hydrogen and helium, the celestial clay from which stars are sculpted. The theoretical upper limit of a galaxy's size, if it devoured all available gas, hovers around 10 billion times the mass of our Sun. But the JWST has not yet uncovered any galaxy near this theoretical limit. Instead, it has stumbled upon a cosmic surplus, hefty early galaxies far more massive than anticipated. JADE's galaxies, weighing in at about 100 million solar masses just 330 million years post-Big Bang, and SEUS galaxies boasting over a billion suns worth of stars a mere 450 million years into the cosmic chronicle, challenge the limits of rapid matter assembly in the cosmic spring between the Big Bang and the cosmic now. Astronomer Caitlin Casey suggests that perhaps some of the stellar radiance doesn't emerge from stars directly. Could it be that the light is a celestial dance orchestrated by ionized gas nestled between stars in the throes of formation? If so, these galaxies might not be as massive as their luminosity suggests. Now, this is really surprising and definitely out of the box. As astronomer Robertson wisely puts it, unraveling the mysteries of early galaxies is the key to deciphering the origins of our cosmic home. This is where the story begins, at redshift 10, the origin of our cosmic existence. Let me introduce the universe breakers, a set of galaxies that defy not only the norms of galaxy formation but the very theoretical foundations of our universe. 6 celestial anomalies spotted with SEERS have grown to such colossal proportions in the mere blink of cosmic time that they've earned the endearing nickname from astronomer Nelson, the universe breakers. With photometric redshifts between S and N, indicating a cosmic upbringing within the first 800 million years, these celestial giants boast stellar masses rivaling or surpassing our Milky Way at a staggering 60 billion solar masses. Mike Beneculin, an astrophysicist from the University of Texas at Austin, throws a cosmic spanner into the works. The ordinary matter available back then, the cosmic atoms at the disposal of budding galaxies, would have had to transform entirely into stars to birth these universe breakers. It's a daunting challenge, and as Beneculin succinctly puts it, it's very hard to accommodate them in our current models. Dark energy, the elusive force propelling the universe to expand, emerges as a potential protagonist in this cosmic drama. By injecting a dose of early dark energy, theorists speculate we might witness bigger reservoirs of atoms and faster cosmic evolution. Could these universe breakers be the result of supercompact early galaxies efficiently converting all their gas into stars before the oldest stars unleash their cosmic finale in a supernova, dispersing the star stuff? Astrophysicist Avis Heil and colleagues proposed this alternative, a cosmic explanation that doesn't break the universe but merely bends its rules. A spectrum analysis of one of them reveals not a universe breaker after all, but a galaxy at redshift 5.6, with a voracious black hole adding its glow to the cosmic spectacle. The cosmic drama continues, and the answers may rewrite the very rules of our cosmic narrative. Roughly 50% to 80% of the galaxies they studied appeared flattened in 2 dimensions, akin to long, thin breadsticks. The unexpected twist: these breadstick-shaped galaxies were more common in the early universe, a surprising departure from the round galaxies prevalent in our present-day cosmos. Virg Piea, a NASA Hubble Fellow at Columbia University and the lead author of the study, opens the door to this cosmic mystery. He speculates that the answer may lie in the cosmic highways formed by filaments of dark matter. These filaments, like a skeletal background, may have guided gas and stars, shaping galaxies into the unique breadstick forms observed in the telescope images. The team, using the James Webb Space Telescope's Cosmic Evolution Early Release Science Survey, sifts through a vast field of near-infrared images. The galaxies selected for analysis are estimated to have existed when the universe was 600 million to 6 billion years old. The findings are captivating. Galaxies resembling pizza pies and balls of pizza dough also make an appearance. But what about our own Milky Way galaxy? If we could turn back time by billions of years, would it have looked like a breadstick, a pizza pie, or something entirely different? Haowen Zhang, a PhD candidate at the University of Arizona, proposes an idea. Our Milky Way might have appeared more like a breadstick in its early days. The evidence stems from theorized estimates of the Milky Way's mass billions of years ago, revealing a possible connection to the elongated galaxies observed in the early universe. The cosmic enigma continues, and recent data from JWST challenges the very fabric of our understanding. A paper fresh off the press reveals that objects older than the universe itself have been spotted. Yes, you heard it right, galaxies that predate our known universe. It's a cosmic enigma that has scientists scratching their heads. Now, scientists are cautious, awaiting peer review to confirm these mind-bending discoveries. But let's dive into what we know so far. The JWST has shattered records, surpassing the Hubble telescope's findings. The most distant galaxy ever observed, JWST 13, existed a mere 325 million years after the Big Bang, putting it at a mind-boggling 33 billion light-years from Earth, thanks to the universe's expansion. Among these distant galaxies, one turned out to be an imposter, a dust cloud playing cosmic hide-and-seek, fooling our observations and challenging the very tools we use to understand the universe. The JWST may have glimpsed galaxies even closer to the Big Bang, galaxies that throw our established cosmological model into disarray. And just when you thought the roller coaster was slowing down, the JWST unveiled another surprise. Our conventional model predicted a certain order in the evolution of early galaxies, suggesting that as we peer deeper into the past, galaxies should become less organized and smaller. But guess what? Recent observations reveal the opposite. Some early galaxies are more massive and organized than anticipated. Nobel laureate Dr. John Mather, senior project scientist for the JWST, sums it up best. We are looking farther back in time than we could before, and we are really thrilled with this picture. But the plot thickens. Galactic giants, galaxies like SEUS 212, resembling our Milky Way, emerged just a few million years after the Big Bang. This defies the expected timeline for the formation of spiral galaxies, challenging our understanding of galactic evolution. Shortly after the Big Bang, when the universe was in its infancy, just 500 to 700 million years old, our expectations were clear. We anticipated the birth of young, small galaxies emerging like cosmic infants from the dark ages. The first stars were to be like eager toddlers, shining bright blue with the promise of youth. But the images captured by the Webb's near-infrared camera during its early observation campaign unveil a cosmic anomaly. Giant, mature galaxies, hefty enough to rival our own Milky Way, appear as tiny reddish dots in the telescope's field of view. It's like finding a grizzled elder in a nursery filled with newborns. Nobody saw this coming. These galaxies, massive and full of mature red stars, defy the expected narrative of the early universe. Astronomers expected the galaxies of this era to be like children playing in the cosmic sandbox, not fully formed and certainly not adorned with the celestial wrinkles of age. These galactic giants, however, are challenging the very fabric of our understanding. Joel Leah, an assistant professor of astronomy and astrophysics at Penn State, raises an eyebrow at the celestial enigma. He remarks, "We had specific expectations for young and small galaxies that live in the early universe. They are young and small. This was astounding. We're finding galaxy candidates as massive as our own galaxy when the universe was only 3% of its current age." The Hubble Space Telescope, Webb's predecessor, painted a different picture with its less powerful lens. Previous observations suggested a universe filled with small blue baby galaxies in its infancy. Yet here we are, faced with the stark contrast of mature cosmic behemoths. The stars themselves become protagonists in this cosmic drama. Young stars, like exuberant youth, shine bright blue, while, as stars age, they acquire a redder hue, a cosmic transition from vigor to twilight. However, in the ancient galaxies observed by Webb, astronomers expected to find the celestial equivalent of the fountain of youth, not the twilight glow of aging stars. Leah urges caution before we rewrite the textbooks. He warns that before astronomers start rewriting cosmology theories to explain how these galaxies came together so quickly, we need to ensure that we are identifying galaxies and not just their glowing stars, which might be distorting our perceptions. This discovery still needs further study. But one thing is clear: the cosmic timeline is more convoluted than we could ever have imagined.